Hey gang, in this video we're going to review a lot of the information you learned in Algebra 1 about linear functions, specifically standard and slope-intercept form. So going back to square one, when points on a graph lie along a line, that is what we call a linear function. So any graph that's a line is part of that function family. Linear functions we can represent by equations, and for example, this graph here could be represented by the equation x plus y equals 8. This equation is in what we call standard form, and so that's the first form I want to talk about and review with you here in this video. Standard form is written in this form here, ax plus by equals c. X and y, notice, are on the same side of the equal sign. A, B, and C are all integers, meaning there are no fractions or decimals in standard form. A couple of other things. A is always positive in standard form. Okay, A is always positive. And this last part here says the GCF of A, B, and C is 1. All that means is that A, B, and C are not divisible by any number besides 1. Okay, and that's how you know you have standard form for a linear equation. So we're going to practice this form now in examples 1 through 3. We're going to take the equation we're given and rewrite it in standard form. So number 1, we have y equals 2x minus 9. One thing we know about standard form is that x and y have to be on the same side of the equal sign. So we're going to subtract 2x from both sides in order to get x and y both on the left side of that equal sign. So that gives us negative 2x plus y equals negative 9. Another thing about standard form is a has to be positive, and so here we see that your a value is negative 2, which is not standard form, so we have to divide everything by just a negative 1. Okay, we're going to divide by negative 1 in order to change the sign on that a value, and so that gives us positive 2x minus y equals positive 9. So this would be a standard form equation here. Okay, number 2, 9x plus 6y minus 24 equals 0. X and y are both on the same side, so that's good. The minus 24, we need to move to the other side of the equal sign, so we'll add 24 to both sides. That gives us 9x plus 6y equals 24. And at first glance, it may seem this isn't standard form, but 9, 6, and 24 are all divisible by 3. So really, to get this in standard form, I need to reduce my coefficients to be as small as possible without getting fractions. So 9 divided by 3 is 3, so we have 3x plus 2y equals 8. Would be your standard form for number 2. Number 3, 3/4 x minus 1/3 y equals 1. Your a value, your x term is positive, x and y are on the same side of the equal sign, so that's all good. But we have fractions for a and b, and standard form does not have fractions, so in order to eliminate these fractions, we need to multiply by the least common denominator of our fractions. The LCD of 4 and 3, that would be 12. So I'm going to multiply the left side and the right side both by 12. So on the left, distribute my 12. 12 times 3/4 would become 9, so this is 9x. 12 times a negative 1/3 would be a minus 4y equals 1 times 12 is 12. Okay, so that's standard form. We also have what is called slope-intercept form, and oftentimes you'll see linear equations also written in slope-intercept form. Slope-intercept form looks like this: y equals mx plus b, or sometimes you'll see it written in function notation: f of x equals mx plus b. In this form, the m is the slope, and the b is the y-intercept. So we'll practice with this form here in just a little bit on the back. I want to really quickly dive into slope as well and review that. So remember, slope is the rate of change, the constant rate of change between 2 points on a graph. And when we're talking about graphs, usually we define slope as the rise over the run. Okay, it's the vertical change over the horizontal change. There are 4 types of slope, and we're going to sketch those here below. First type of slope is positive slope. Okay, so positive slope always results in an increasing line. Okay, so anytime a line rises from left to right, so for example, this line here, you know you have positive slope. Negative slope would be a line that is decreasing. So a line that has negative slope might look like this. And then we have zero slope, which is neither increasing nor decreasing. It's actually a flat line or horizontal. And then we have what's called undefined slope. And undefined slope gives you a vertical line. Okay, so it's important to know and recognize those four different types of slope. It's going to make your life a lot easier when you're doing the graphs of different linear functions, is recognizing what kind of slope you have and then making sure your graph matches correctly. So now we'll go to the back side, and we're going to practice number one, changing these equations to slope-intercept form, and then number two, graphing our lines. Okay, so number 4, we have the equation x plus 3y equals negative 15. This is an example of standard form, but we want to change this equation to slope-intercept form, to y equals mx plus b. So to do that, I need to solve for y. So I'm going to subtract y, or subtract, excuse me, not y, subtract x from both sides. So that's going to leave us with 3y equals negative x minus 15. And then we want to isolate y, so we need to divide everything by 3. So this is going to give us the slope-intercept equation, y equals negative 1/3 x minus 5. From this form, again, we can identify two things. We can identify the slope of the line, which is negative 1/3, and the y-intercept of the line, which is negative 5. So now I can go to my graph and start at my y-intercept, 0, negative 5. And then my slope is negative 1/3, so that means my rise will be 1, my run will be negative 3, so I can go up 1 and left 3 to get a decreasing line. I also have the option of going down 1 and right 3, which will also result in a decreasing line. And once I get a few points on here, I can, with a straight edge, connect my points to get a nice line across the coordinate plane. Okay, number 5, we have negative 4x plus y minus 1 equals 0. So again, we're going to put this in slope-intercept form, so we're going to isolate the y. So that's going to involve adding 4x to both sides. And that's going to give me y minus 1 equals 4x. And then I also need to add this 1 to both sides. So this is y equals 4x plus 1. So the slope of this line would be 4. The y-intercept would be positive 1. So to graph this, I'm going to start at 0, 1 on my y-axis. Since my slope is 4, again, that's a rise of 4 and a run of 1, I can go up 4 and right 1, and up 4 and right 1 again, or I can go down 4 and left 1. Again, pay attention to the sign of your slope. Make sure you know, since this is a positive slope, your line should be increasing at the end, and this is increasing. Okay, so that's graphing and changing to slope-intercept form. Moving on, we're going to talk about vertical and horizontal lines. So in example 6 and 7, you see one of each. A vertical line, remember, is a line that has undefined slope. And to write the equation of the vertical line, you just have to look at its x-intercept. Okay, what is the x-intercept of this vertical line? Well, its x-intercept is here at negative 3, 0. So the equation for this line is just going to be x equals negative 3. In fact, every single point on that line has an x-coordinate of negative 3. And then the opposite is true for number 7. This is a horizontal line, every single coordinate, every single point on this line has the same y coordinate, and so the y-intercept of this line is 0, 1. So the equation of this line is just y equals 1. So vertical lines, just remember they always start with x equals, and it's just the value where it crosses the x-axis. Horizontal lines, it's y equals where it crosses the y-axis. Okay, they only have one variable in each of their equations. Okay, the last topic for this video, parallel and perpendicular lines. So we know from a geometrical standpoint that parallel lines are those that never touch, and perpendicular lines are those that cross at 90-degree angles. But from an algebraic standpoint, we compare parallel and perpendicular lines by looking at their slopes. So the slopes of parallel lines are always equal to each other. And if you think about that for a second, it kind of makes sense. Okay, in order for one line to be parallel to another line, they can never actually cross, so the rise compared to the run has to be the same for both lines. Otherwise, eventually one would intersect the other at some point on the coordinate plane. Perpendicular lines, their slopes are not equal to each other. In fact, their slopes are always related in a special way. Their slopes are, number one, always opposite of each other. And number two, they're always reciprocals of each other. So if one slope is negative, the other must be positive. And then reciprocals, if one slope is, say, positive 1/3, the other slope would be negative 3. Okay, so that's how we compare the slopes of perpendicular lines. So in these last few examples here, I've given you two equations for each, and you're just going to tell me whether the pair of lines are parallel to each other, perpendicular, or neither. And we'll start with 8. We have 10x plus 5y equals 5, and negative x equals 2y plus 16. So the easiest way to do this is to change your equations to slope-intercept form, because we have to identify the slopes in order to tell whether they're parallel, perpendicular, or neither. So for 8, I can subtract 10x from both sides for my first equation to get 5y equals negative 10x plus 5. Then divide both sides by 5, and I get y equals this would become negative 2x plus 1. So the slope of my first line here is negative 2. The second line, I have y on the right side of the equal sign, so I can subtract 16 from both sides to get negative x minus 16 on the left. So I have negative x minus 16 equals 2y. And then I can divide everything by 2. And that's going to give me a negative 1/2 x minus 8 equals y here. So here my slope, again, it's the coefficient of x is going to be negative 1/2. So if we compare negative 2 and negative 1/2, obviously these are not the same slopes, so these are not parallel lines. Negative 2 and negative 1/2 are also not opposites of each other. They are reciprocals, 2 and 1/2, but in order for lines to be perpendicular, one slope has to be positive and the other has to be negative. Since these are not, this would be a neither situation. These lines are neither perpendicular nor parallel. Okay, number 9, 8x minus 6y equals 42 is my first equation. So I can subtract 8x from both sides. That would be negative 6y equals negative 8x plus 42. And then if I divide everything by negative 6, negative 8 divided by negative 6 gives me a slope of 4/3. So y equals 4/3 x, and then this would be a minus 7 here. So the slope of this first line, again, is 4/3. The second line, all I need to do here is divide by negative 3 to isolate y. So this would be y equals 9 divided by negative 3 is negative 3. Negative 4 divided by negative 3 is positive 4/3 x. So this equation, if we switch our x term and constant term around, is y equals 4/3 x minus 3. So the slope of this line would be positive 4/3 as well. So we have equal slopes here, and therefore these are parallel lines. Okay, number 10, negative 8x plus 8y equals 0 is the first equation. I need to add 8x to both sides so that I can get 8y equals 8x. And then I can divide both sides by 8, and that's going to give me y equals x for this equation. So think about what the slope of this line would be. If it's y equals x, well, the coefficient on x is 1, so we have a slope of positive 1 here for the first equation. Second equation, I can subtract x from both sides, and I get negative y equals negative x plus 4. Then I need to divide by negative 1 to get y by itself, so this becomes y equals positive x minus 4. Here, I also have a slope of positive 1, so I have two slopes that are the same, and therefore these lines are also parallel. Okay, number 11, x equals 2 and y equals 2. There's really not a whole lot of work to do for these. These are both examples of vertical and horizontal line. And if you know anything about vertical and horizontal lines, hopefully you can see that they always intersect at right angles. Okay, a vertical line and a horizontal line will always intersect at right angles. Remember, the slope for a vertical line is actually undefined, and the slope for a horizontal line is 0. But if I were you, I would just again picture this vertical line and this horizontal line intersecting, and so those would be perpendicular. Okay, if you had any questions over this video, again, it should have been mostly review from last year, but obviously if there's something that didn't make sense, make a note of that so I can take a look at that the next time I see you in class. Until then, have a nice day. You're all wonderful people.